Next, we are going to consider analysis problems. Problems number 2, 10, 9 in the textbook. Okay, this is analysis problem. The previous example is design problems, but now it is analysis problems. Let's consider a simple beam again, a simple beam, but now it is rectangular section. Okay, now let's see. The beam has a length of 5 feet. Okay, 5 feet. Then it is unknown, and that's why we call it is analysis problem. Then section is rectangular section. The height of the section is 2 inch, but the depth of section is 2 inch, but the width of the section is changed from 1 to 3 inch. Okay, you can understand. B is a function of x. It changed. So x, let's say here x equal to 0 here, then x changed. So b is a function of x. Then I will show you how it changed. Then we have to determine the load, distributed load for collapse of the beam. Okay, now see here. First, let me explain the section. It is section. So here is the bx. Okay, bx. Here is 1 inch at the bow end of the beam. Is 1 inch, and at the middle, bx is 3 inch. Then from here to here it changed. Then bx equal to this equation. Okay, so bx, this equation equal to bx. So the width of the beam is changed. Remember. Then we have, this is the moment diagram of this beam, right? So you know the moment diagram of this beam, and you can determine m as a function of x. What is mx? Okay, so x from 0 to maybe 5 equal to what? It is a function of x and what? Sorry, mx is function of what? X and w and maybe l equal to 5, right? Okay, so here mx equal to 5 multiplied by w divided by 2. It is reaction. Okay, reaction, then minus half of w multiplied by I square and multiplied by 12. 12 is convert that from the feet to inch. Okay, then it's equal to this one. It is mx, the function of the equation or function of the moment diagram. Okay, so remember this is a function of moment diagram. And what else? mpx. mpx means the moment of the section. Moment of the section. Remember, because the section is changed. Okay, the section is changed. Then mp is changed as a function of x also. Okay, mph. Then we can calculate mph and mp, but the function of x because the section is changed. Then now we have mpx equal to sigma y multiplied by zx. Of course, g is changed due to the change of the section. Sigma y multiplied by b bx multiplied by t d. It is d, okay, or 2d equal to 2 square divided by 4. It is dx, okay, it is dx. Then equal to this one. So we have mx and we have px. Mx is moment due to the load, okay, due to the applied load on the structure. And here's mpx is moment of the section, elastic moment of the section. It changed due to the change of the section. For design, no, for equilibrium condition, mp, we have the outer curve is mpx and inner curve, okay, inner curve is mpx, okay. Then mpx or mx should be smaller than or equal to mpx, okay, equal to mpx. Should be smaller than or equal to mpx, and it touch each other at some point, maybe one point. We know this point or this point, okay. So at this point, what is condition? What is condition of this point? The derivative, okay, the derivative. So at this point, the slope, okay, slope of the inner curve and slope of outer curve should be identical, okay, should be identical. So we have two equations. The first equation is mx should be equal to mpx, okay, and the second condition is the derivative of mx equal to the derivative of mpx, okay. Can you follow me? Okay, I will show you. First condition is, because we have two unknown. First unknown is w and the second unknown is x here, the point here. Then the first condition is mpx equal to mx. It is a strength condition. And the second condition is the derivative of mpx over dx equal to dmx over dx. Okay, this is slope of the inner curve. Okay, then this one is slope of the outer curve, and at this point it should be identical. From two equation, two condition, we have two equation. The first condition has this equation, okay. Then the second condition becomes second equation. So now we have two equations with two unknown, right? W and x. Two equations with two unknown. Then it is very simple for you as a graduate student. You are very smart, and can solve the equation very easy. And here W equal to 2.51 keep per feet, and X equal to at this point. But we just consider this it is final solution, but you have to show both. Okay, so let's say in homework or in exam, you have to show also the value of W and value of X to get the highest score. But in the practical design, maybe only require the load, apply load, the value of maximum load is required. Okay, so we have solution. Okay, so there are many examples. Okay, there are many examples in the book. So please check in the book from page number 83 in this book, 93, the section 210. Okay, the section 210. We have many examples on analysis and design or determine the value of plastic section modulus or elastic section modulus or shape factor also. So many problems due to a limitation of times. I cannot show you every example, but I recommend you are recommended to read the following example. I will show you only problems, but you have to you should read, okay, the example in the textbook. Okay, for example, the first is example 210.1. Okay, example 210.1. How to determine plastic section modulus, elastic section modulus, and shape factor of different section. For example, this section, okay, I section, we have the dimension of section, then it is required to determine G, S, and F of the section in both the strong axis, okay, and weak axis, okay, strong axis and weak axis. You have to determine both. Or this type of section, I section with the upper steel plate, okay, cover plate, steel cover plate. Also determine the E and S and F of this section. Okay, or this section. One of the example I already explained is this section, right? And you also know about that. Or this type of section, okay? It is not a normal section. Please check G and S and F of the type of section. Or this section, okay, this section. Or triangular section. So let's say 1, 2, 3, 4, 5, 6 different sections. In this case, we need to check in both strong and weak axis. Okay, so you don't need to calculate, you don't need to do, but you have to read. You need to read how they calculate. Okay, very simple assignment, right? Simple assignment. But remember, you may see one of them again in the exam, so that's why I recommend you to read carefully. Okay, maybe in the exam maybe a midterm exam or final exam, I will give one of the similar problems. And another example is 2.10.3 in your textbook. Okay, it is design problem of I section. Design problem of I section. Okay, then there's required to design for the I section with the given condition, some condition. Okay, so here we have the total width and total height of the section and the width of the section. Then you have to determine t small t and t of the wave and t of the length, thickness of the wave and thickness of the length. Then please see in the book how to solve the problems and remember the procedure. Or example 2.10.5. It is analysis problem. Okay, analysis problem. We have to determine MP and MPC. MP means without the effect of the action force, and with effect action force. And of course, action force may be provided. Okay, then you have to determine also MPC of this section. So the previous section is I section. But now the I section with both steel cover plate at both flank, upper flank and the top flank and the bottom flank. There are steel cover plates. Okay, so this is steel cover plate. In some case, we have to use the steel cover plates for the real structure. Then analysis problem. Analysis means determine MP or MPC due to action force with the given section. Maybe, for example, if the section is used with sigma y equal to sigma t or equal to sigma c, but sometimes sigma t is different from sigma c. Okay, it means it is compression sigma c and it is tension sigma t. Sometimes it's equal, but sometimes it's different. Okay, so be careful. So maybe in example, exam, I give you, for example, this one is sigma 1.5 of sigma y. Okay, and this one is sigma y. Then problem is changed. So think about that, and if you have time, please practice to calculate with different case. So this is an assignment for you. You don't need to submit to me, but you have to study for exam. Okay. The problems 2.10.10 determine the load factor, okay, of this structure. It is cantilever beam, okay, cantilever beam with the contributed load at 2 points. Let's say is B and C, B and C, and it is shift shear diagram, and it is a moment diagram. Then of course in this case shear force, the effect of shear force should be considered. And it is section, and it's required to determine the load factor of the cantilever beam. And please see how they determine the load factor of this cantilever beam. Okay, then see and check, and maybe the problems maybe meet again in some case homework or no in exam. Okay, so it means, okay, I will give you more example on homework. Okay, or homework. Sorry, here is homework number 4. Okay, homework number 4, not 2. Number 4. Homework number 4. Thank you very much for your listening.